guys.
Hi there, I'm Sasha from Coding Rooms.
And I'm Angela from Coding Rooms, and we're back today with another segment of our podcast. So as always, we'll start off with our product updates, and then today we have a very interesting topic to explore, and that is all about programming being really a creative career, which is not talked about enough in the industry, or I think in education as well. So really want to explore that topic, and then really ending it on how it impacts education and in terms of how students learn more of a creative process when it comes to programming. So without further ado, I'll pass it over to you to give the product updates.
Thanks, Angela. So this week, piggyback off what we talked about last week, which again is one of the longest product updates we've ever had to do in the 5-episode history of this podcast. So the very first thing is that we shipped version 2 of conferencing, and now it is actually opt-out. So if you want to continue using legacy conferencing, you have to check a box that will be remembered whenever you create a classroom that you want to use the old version of conferencing, and we're keeping that open for as long as users need until we have full feature parity. But so far the acceptance of the version 2 has been really great, and the stability that it offers and UI UX improvements have been similarly positive. So that's why we made this second step in terms of availability of the version 2. The other thing is we shipped alongside that an updated chat. So this updated chat is now fully persistent, so will last for the lifetime of your classroom. It includes the ability for students to also have conversations on the platform amongst themselves. It enables the instructor to manage a group chat and with the following moderation features. And it also integrates with browser notifications, so even if you tab out, you'll be able to see all the different notifications if you opt into that. We're also shipping within the chat the ability to send files in the upcoming few weeks, and so we'll let you know when that ships. We also ship student workspaces. So student workspaces now allow students to go through their Coding Rooms account to create a project on Coding Rooms and code in real time with their friends for group projects, for example, and to copy that link and share it out to, let's say, a learning management system Dropbox, or just share it with their friends to share example code. And that's the same real-time IDE that we have in the classroom, except of course it's just a single IDE as opposed to the classroom where you have all the student IDs. We also shipped assignments, which is kind of related to student workspaces because it plugs into our IDE environment. And this enables students to actually make submissions for assignments that you create on the platform. Alongside assignments is a whole suite of auto-grading functionality. So you're able to create unit tests and create manual grading tests, and also to create input-output matching tests. And there's a lot of new stuff that you can do with that on Coding Rooms, and that's in general availability now. We also shipped the interactive terminal, which enables students to have basically what is a full sort of collaborative terminal for a fully set up Linux machine on Coding Rooms. They can spin them up and terminate them, reset them throughout the duration of their workspace or their classroom. And also everyone who's viewing that terminal sees it interactively. So you can even do things like open up Vim or Emacs, and everyone will see you editing in real time. And finally, an upcoming feature is assessments, which ties into what we shipped with auto grading and assignments, except for it's meant for like exams where you have a time-boxed type of testing use case. And that will enable students to go through a set of multiple questions, do all their coding, submit their results, and then ultimately for you as the instructor to be able to see a full analytics dashboard and verify the authenticity of their submissions. So with that, I'll hand it back over to you, Angela, for the rest of the podcast.
Yeah, so very exciting stuff as always, and be sure to check out our website for our blog as well, where we posted some of our recent product updates, and also how you can toggle the conferencing. So, we defaulted to the new conferencing, but if you were to really want to use the old legacy one, we still support it, and there's instructions on that. So we'll link it in the description as well after the live stream. So now on to our topic this week. We really wanted to start exploring this kind of stereotype that programming, coding, computer science in general is, because it's STEM focused, it's very mathematical, logical, and, you don't typically associate it with creativity. However, there is actually a lot of creativity when it comes to programming or coding in general. And we want to kind of explore the different ways that being a programmer, you would have to leverage a certain type of creative process. Like, it's definitely still computer science, it's definitely still very mathematical and logical based, but together in terms of actually, building pieces of software or creating projects, it does require a lot of creative thought processes. So just starting off, kind of taking it back a step, in terms of just software architecture, like from a very broad perspective, even
that's a big job, of course, because we cover a lot of different things that student teachers want to do. And of course, Coding Rooms, our motto is built with love for teachers and students. So we want to make sure that all that is as reliable as possible and works as well as possible. And that involves a lot of creative decisions where there's no real answer, or no real correct answer, let's say. Hopefully there is an answer, and we're finding at least one of them. And that process, I could sort of personally attest to it, is incredibly challenging and requires a lot of sort of creative and out-of-the-box thinking, where we apply our understanding of systems, of computer science, programming, of software architecture, systems architecture, right, to create solutions that fit our use case. Because in school, for example, we learn how to build quality software using, let's say, object-oriented programming techniques. But when you're building a real project, you have to have the creativity to figure out exactly how to apply them. And I would say that there's a lot of deviations from the standard, or from at least, let's say, the traditional standard, that are required in order to build the best software. So even though we might mix standards or deviate from standards, it actually delivers better software faster. And that requires making a lot of judgment calls, let's say, and also having a open mind to building all the things that we build at Coding Rooms. Now, when it comes to teaching, I really feel that it's absolutely crucial to include open-ended assignments and projects for a multitude of reasons, namely the fact that it is more engaging. So even though students might initially be opposed or frustrated by open-ended assignments that, let's say, seem to have, let's say, no real sort of quantitative
solution.
It's a solution or set of outcomes, right? In fact, those once students, again, I kind of let's scope this conversation to not super intro students, because super intro students kind of
they need the basics. They need that kind of just the theories, the syntax, like all that kind of more dry stuff compared to more advanced.
And then there's also like plenty of games to like make those more creative. But the even if those things are creative, they're not usually creative in the programming solution. So you might be able to like choose which color, but actually that's not the creativity that we're talking about.
Yeah, we're talking about like actual problem solving, like applying all these theories, all your knowledge of computer science, computer engineering, and actually tying it all together to actually create something, like being a creator.
Yeah, exactly. And that's sort of let's say a different form of creativity than just like choosing a color, right? I mean, it's also harder to define like what is a creative solution for a challenging engineering problem. Some solutions are obviously creative and obviously horrible, right? I mean, it's like, oh, you have a really creative solution to get past this firewall, but that's also horrible. Yeah. So it's also really kind of this is a challenging topic, and that's why we didn't do this on our very first podcast.
Yeah. And I think this could create a whole segment too, because there's so many different like layers to this, and so many different facets that we can talk about in terms of creativity. Yeah. But I think today's podcast is going to be really broadly just introducing this subject.
Exactly.
Yeah. But I think, whether it be just like creative solutions to actual functional problems, like for example, if you are creating a software, it's all about speed, performance, optimization, and depending on how there's definitely in terms of writing code as well, there's good code and there's bad code, and there's different styles. This all kind of functions together in this ecosystem of creativity when it comes to being an engineer.
But definitely this is a thing I'm actually really passionate about, is building code that's made for teams. So at coding rooms on the back end, almost our entire system on the back end again is written in Go, which is it's a relatively new programming language. And by relatively new, I mean I think it's about actually just the other day it turned 11 years old. I was reading on Hacker News. It's an 11-year-old language, which is very new as far as sort of stable production ready languages go, and I would say it's really meant for teams. The reason being, it's super easy to read. It's very easy to understand for anyone with a sort of traditional computer science background or programming background. It comes from typical language like Java or C, C++. It's very easy to understand. And it's also kind of harder to get wrong, let's say. And this hard to get wrong, easy to understand, I think is actually almost a requirement to create creative solutions, because coding rooms have a lot of neat creative solutions for doing things, but we also want to make sure that they are easy to secure, that they are easy for other developers to understand, that they work, right? They don't have obscure bugs because of like some crazy edge case that no one could have possibly foreseen because of just like the way the programming language is written. And again, this kind of ties back to the topic of creativity, because a lot of times I feel like creativity is, hey, I took this 10-line block of code and I turned it into 1 line. Yeah. But that's horrible. That, to me, when I hear that, I think, oh my God, stop what you're doing. Leave the room, like go get a coffee and come back and like work on something else.
Is it like let me just like let's bring it back down to just like layman terms. Like for you say that because then all of a sudden you lose that thought process, or you want to see like
well, sort of, right. The main thing is most likely is if it took a strong, like, thoughtful engineer 10 lines to write it, there's probably a reason why. And B, probably it's much easier to understand than your 1-line solution. Yeah. And your 1-line solution might be super creative, but it's also horrible, because if I ever want to debug that, I probably have no freaking idea like how to even start looking at the solution that you built. You might be the smartest person on earth, but it really doesn't matter, because you at some point are going to stop working on this project, or you'll add more people to the project, and you're gonna have other people look at this code and be like, oh my God, can we call the person who wrote this and ask them what in the world they were thinking?
Yeah, and I think that it's become a key indicator as well nowadays in terms of what makes good code, and certain code, bad code, because I think everyone now understands that to be a good developer or to actually really write beautiful code is that someone can come in having no like sort of prior knowledge and easily follow your thought process, logic, and just look at it and understand it.
I think that's a huge aspect of creativity. Frequently, that's not really talked about, especially if you look at your typical computer science course, let's say, where you're doing, so let's say more of like algorithms and data structures course, where you're building usually complex solutions to complex problems, and it's sort of by definition challenging. But if you write bad code, or you write code that's creative in the wrong way, you're making it even harder. And usually the person who's debugging the code is you. And so why would you make the problem for you in like 10 months when you're debugging like some crazy edge case harder than it already is? I mean, to me, that's mind-boggling. And also, we talk about this in a lot of different other contexts where there are, let's say, languages or frameworks that are really creative, and I don't want. I mean, actually, I will comment about like a very particular framework, React JS, which is super popular, that I'd say relatively against for a number of reasons. It's a JavaScript based framework, and I'm relatively against it because I think it leaves way too much up to the developer, right? So if I'm a developer, I'm building a React project, I could choose everything, which is kind of cool. Also really horrible because the next person who's on this project or the other person who's on this project probably doesn't know what I was thinking, and probably I didn't leave good docs, and now this is kind of like anyone's guess how to get at it. And the other thing is there's a lot of this sort of black box magic. And this black box magic and unspoken rules and all this type of stuff is kind of all right if it's well documented, pretty static, and also is in a framework that allows easy discovery. So even if it is a black box, sort of, let's say it's abstracted away, if there is a way for me to at some point like really easily get in there and figure out how it works, or at least understand the mechanics without reading code, it's really great. And frankly, I think one, again, super popular framework, React, does a negative job with this, does a poor job with this. And at the same time, it forces like an oddly huge scope of knowledge on developers, especially on front-end developers who frequently, let's say, are not coming from a traditional computer science background.
Yeah, and I think you mentioned a good point, because I feel like in a lot of just very broadly speaking, I think it's something that we should explore more of, educators and us as well, being in the ed tech space, is really evaluating how this ties back to education in how it's being taught, whether it's in a K-12 level or a collegiate level. Because I think, there's not enough emphasis, like to your point, there's not enough discussion around this where, suppose like, future curriculums, as they start to see that, beautiful code, good code is one that's easily understandable and the logic is just beautiful. That maybe you should have more projects where a certain percentage of your mark is, getting just your other classmates to look at your code and have some sort of rating. Because that's the real world here, right? I mean, we talk about learning in classrooms, but what are you really preparing for? You're preparing for eventually being in this industry or doing actual practical things using the skills you learned. And yeah, I think it's an interesting area that needs to be more emphasized and explored.
Yeah, and frequently, your grade comes from the correctness of your solution, and the correctness is several sort of steps removed from the quality of your solution, right? And that's certainly something to think about, particularly at the university level, because I'm pretty tired of interviewing developers who just graduated who don't value this.
Yeah. Yeah, and I mean, it's not to their fault. Maybe they just never really learned it in school. Maybe it's their particular program or whatever it may be, but it's definitely something that that I feel like it needs to be more emphasized. And they do say that. I think intro CS classes, they always say, oh, you know, your runtime, your all this stuff.
But that's a great example of a negative thing. So runtime. Should you know the difference between a n squared solution versus O n log n or log n or O n? 100%. Is it always the best solution to use the O n squared use the O n versus the O n squared if the O n is like 10 times more complicated to write? Even though it is, by any kind of computer scientist perspective, the best solution to use, it might honestly be the worst solution to use if you're on a team and you have like real problems to solve and you have a schedule, and you can, as a computer scientist, make the sort of, let's say, creative decision to say that, hey, actually, we're only processing maybe, let's say, like 100 records here on average. So actually, if we use the O n squared solution, it's not that bad. And runtime looks good, and it's a lot simpler, a lot easier to debug, and if this becomes a bottleneck, we can come back to it. That's actually the much more mature solution, and because probably reading the O n squared solution is much easier than reading the O n solution, right? It's this again is like a place where I don't think it's emphasized enough in the vast majority of computer science curriculums that you really have to choose the solution for the specific problem that you're solving, in addition to thinking about the other people on your team who will have to deal with the pile of junk that you just created a pull request for on Git. You know?
Yeah, no, I think you bring up a good point, because that to me is also another aspect of this whole creativity subject that we're talking about in this podcast, because it is thinking outside the box, because you're learning all these computer science theories in school, and there's definitely, like, to your point, you have to know it, but it's taking that extra step and thinking more like a creator, a team player. Because in the real world, I mean, if you were to build something like on a large scale, you need a team. So you need to be comfortable with working with other people, especially in terms of how your code looks and the logic.
Exactly.
So I think that, tying, like, kind of like, I guess, tying this all off and embodying it really is, how does it impact, like, education and just how we should encourage students to think, is that, we really have to hone in on this idea that, when you choose to be in computer science, or when you choose the subject area, what do you want to get out of it? Because if you want to be a creator, that's very different from someone who just knows how to code, or not a creative programmer, more just like, hey, I know it as a means to an end, not as a creative solution.
Yeah.
Yeah.
I would say also there's a great deal of confidence building that a solid computer science curriculum ought to give to students, because remember, and maybe rightfully so, let's say, I for a long time didn't have the confidence to figure out how to build my own solution. It's also not always good to build your own solution. It's probably best to just pick up an open source solution, kind of like dissect it, maybe just integrate it directly, or copy or just copy that open source solution into your code, adhering to the licenses and all that kind of stuff, and maybe contribute back. But you have to be able to, at some point, sort of toe that line between confidence to build yourself the reason to build yourself, how to build it by yourself or with your team, and sort of yourself in the sort of more general sense, and how that will ultimately impact something like a business goal or a product goal. Because that's all that matters, right? I mean, at Coding Rooms, we basically say that we do two things, right? We build our product and we talk to users, right? And so everything that we do at Coding Rooms has to fit into one of those two things: how to build the product better or talk to users more. And that's something that I think, with a highly project-focused curriculum, again, at a certain level of computer science knowledge, of course, has to really hone in with all your students. That they have to understand this kind of stuff. Otherwise, they're going to be the really annoying guy on the team.
The one that's always telling you, no, this guy, what I wrote is good. I think it's also taking feedback, right? That's like another thing. It's like a trial and error. It's like building on yourself and learning from others. It's all part of this ecosystem.
Exactly.
So I think, I think this is great intro to this conversation. I think going into it, I definitely think, it's definitely going to be broad. And we might actually even have a whole just segment on this, like all the different aspects. But I think we wanted to introduce this topic because this week especially, I mean, we started kind of sharing just coding knowledge with each other. We have coding lunches, and it's all about being communicative and being able to articulate your thought process, which I feel like is also very important in computer science curriculums. Like, sure, you typed all this out, but can you explain it to someone else?
Exactly.
Even verbally, not just like looking at it or comments or on code, but even verbally explaining it. I think you would start to realize, like, when you talk it out, maybe you realize, like, hey, now that I explained it to someone else, maybe my logic doesn't make so much sense, or someone's going to give you some verbal feedback. You never know.
Exactly, yeah.
Okay, well, anyway, we're jumping straight to our thought of the week, and it's all about the POC doc. I mean, they don't call it the POC doc. I just played on that. They're called POC, and they're for the Mac OS doc, which integrates itself now onto the touch bar of the MacBook Pro.
Yep. So POC.dev, POCK.dev. I don't work for them. I'm not paid by them. Only discovered them today, and it was
Yeah, you pinged me right away. You were like, oh my God, this is our thought of the week. Like, this is so great. And, like, I love it. And I was like, you know what? Because we're kind of opposites on this. He loves the touch bar. I absolutely have never used it other than for system controls, like volume and brightness. And sometimes it's glitchy. Like, I don't know. I personally still like the button touch. Like, even with the touchpad on the MacBooks, like, I like how it's simulates, like, hey, I'm pressing down on something, although you're not technically pressing down on something. But to each its own. Try it out. I'm going to try it out when I get home. Maybe, I'm going to actually change my mind on the touch bar. But shout out to POC. Yeah,
it actually open source technology, by the way. I didn't look at the project yet to give it a star on GitHub. I think it's pretty awesome, and it's a great example of open source technology that works.
Yeah, and I saw that they also support a whole kind of just they had on their landing page an area for developers to create certain widgets and cool stuff like that. But anyway, check it out. Shout out to you guys. We like you.
We're users.
Yeah, we're users. Okay, see you guys next week.
See you next week.
Bye.
Bye. Bye.